Lesson 11.3a is about probability distributions. 11.3 is easier to teach through a video than is 11.2. Okay, so for number 1, we're making a relative frequency table. That's just a table that says all the possible outcomes. So for this example, all the possible outcomes, if you flip a coin 4 times, you can get heads 0, 1, 2, 3, or 4 times. And then the other part of the table is the probability associated with each of those possibilities. So we learned how to do this in chapter 10. So first let's calculate the probability of getting exactly 0 heads. So the odds of getting heads is 0.5. We want to get 0 of those. The odds of getting tails is 0.5. And since we want 0 heads, that means we want 4 tails. And we need to put a combination in front to account for all the different orders we can have. So for this one, 4C4 and 4C0 would also work, because 4C4 is equal to 4C0. Okay, so calculate that. Okay, so 4C4 equals 1. 0.5 to the 0 equals 1. So all we really need to calculate is 0.5 to the 4th power. 0.5 to the 4th power is 0.0625, or 1 over 16. On the graphing calculators, once you get this 0.0625, if you push math and then enter, so math and then enter twice, you'll see fraction, and it'll change your decimal to a nice fraction. Okay, so the odds, or the probability of getting heads 0 times if you flip a coin 4 times, is 1 over 16. I'll fill that in later. Okay, so now what if we want to get heads once? That means we need to get tails 3 times. So in front we need 4C3, or 4C1 would also work. Okay, 4C3 is equal to 4. If I have 4 people, how many different ways can I choose 3 of them? That's the same as if I have 4 people, how many different ways can I choose 1 person to leave out? Well, there's 4 different people you could leave out, so 4 ways. So this is going to be 4 times 0.5 one time, and then times 3 more 0.5s. Okay, that is 0.25, which is 1 over 4. Okay, for the next one, we want to get heads twice, which means we want to get tails twice, and there are different orders that can occur in. Your 2 heads can be first and second, they can be first and third, first and fourth. The 2 heads could be second and third, second and fourth, or third and fourth. So to account for all those different orders, we have 4C2. 4C2 should equal 6. 4C2 equals 6. So 6 times 0.5 twice, times 0.5 2 more times, and we get 0.375. And if you push math and then frac for fraction, you'll get that that is 3 over 8. Next thing we want to calculate is the probability of getting heads 3 times. So the probability of heads is 0.5. We want 3 of those. The probability of tails is 0.5. We want 1 of those to account for the different places that the 3 heads can be. We do 4C1 or 4C3. The 3 heads can be first, second, and third. Basically, it's a question of where does the 1 tails occur, and the 1 tails can occur in 4 different spots. So 4C1 equals 4. Okay, so if you multiply that out, you get 0.25 equals 1 over 4. So you'll notice that the probability of getting heads once and the probability of getting heads 3 times are the same, and that's because 1 heads and 3 tails is equally as likely as 3 heads and 1 tail, because they're both 50-50. Okay, so for the last one, 4C0 times 0.5 to the 4th, because we want 4 heads and we want 0 tails, this will equal 0.0625, because it is just as hard to get heads 4 times in a row as it is to get tails 4 times in a row, since for each flip it's a 50-50 chance. Okay, so we are done with our relative frequency table. Next thing we need to do is make a theoretical probability distribution. A probability distribution is just a bar graph. So refer to the probabilities from our relative frequency table. On the bottom we have all the different possible totals for the number of heads. So for the total of 0, the probability was 1 over 16, so I make a bar that goes to 1 over 16, and I'll even shade that in. Okay, and try to make all of the bars the same thickness. So for 1, our probability was 1 over 4. And then for 2, our probability was 3 over 8. And our probability for exactly 3 heads was 1 over 4 as well. Probability for exactly 4 heads was 1 over 16. Okay, for number 2, we have a wheel, and you might want to fill in the numbers if you can't see them on your paper. So for the spinner, there are 6 spots, numbered 1, 2, 3, 4, 5, and 6. We need to construct another relative frequency table. So if you spin twice, there are 11 different possibilities. It's kind of like if you roll a pair of dice. There's 11 different possibilities. You can get every number from 2 to 12. You can't get 1 because even if you roll the minimum 1 twice, that's still going to add up to 2. Okay. So To figure out the probabilities for each of these, they're not all equally likely. Let's make a table before we make our relative frequency table. So we have 6 possibilities for the first spin. Put those here. And we have 6 possibilities for the second spin. Okay, so inside this table I'm just going to put the total if those were your 2 spins. So if we got a 1 and a 1, our total would be 2. If we got a 2 and a 1, our total would be 3. If we got a 3 and a 1, our total would be 4. So I'm just going to add up the 2 spins. And you'll notice an obvious pattern. Okay, so now we can figure out the probabilities for each of those totals. Okay, inside the box you will notice that there are 36 outcomes possible. And that's because 6 possibilities for the first spin times 6 possibilities for the second spin makes 36 total possibilities. Out of those 36 possibilities, only one of them is 2. So I'm going to cross that one out. There's only one way to get a total of 2. You have to get a 1 on the first spin and a 1 on the second spin. Okay, there are 2 ways to get a 3. 2 over 36 is 1 over 18. There are 3 ways to get a 4. 3 over 36 is equal to 1 over 12. There are 4 ways to get a 5. 4 over 36 is equal to 1 over 9. There are 5 ways to get a 6. So that one doesn't reduce, 5 over 36. There are 6 ways to get a 7. 6 over 36 equals 1 over 6. There are 5 ways to get an 8. 5 over 36 is the probability of getting a total of 8 for 2 spins. There are 4 ways to get a 9. 4 over 36 is 1 over 9. There are 3 ways to get a 10. 3 over 36 reduces to 1 over 12. There are 2 ways to get an 11. 2 over 36 equals 1 over 18. And there is 1 way to get a 12. Okay, now we have to graph the theoretical probability distribution. Okay. So I want a label. Anytime I make a graph, I want to make a label for it. So this graph is for the sum for 2 spins. Okay, so on my y-axis is going to be the probabilities. And on my x-axis is going to be the different sums that are possible. Okay, when you make your y-axis scale, you want to make sure that you don't go too high or too low. So what I would do is I would look at the biggest probability that we see. So the biggest probability we saw was 6 over 36, which is also 1 over 6. So that was 6 over 36. So I'm going to divide this into 6 tick marks actually. Okay, not perfectly to scale, but pretty close. Try your best, please. Okay, so then each tick mark is 1 over 36. So I have 1 over 36. The next one would be 2 over 36 reduced, 3 over 36 reduced, 4 over 36 reduced, and 5 over 36. Okay, the different possible totals that we had were 2, 3, 4, 5, 6, 7, all the way to 12. Okay, and then we just draw bars for each of those. This one went up to 1 over 36. This one went up to 2 over 36, 3 over 36, 4 over 36, 5 over 36, 6 over 36. Then I went back down. I'm going to try to make these neater for the second half. Okay, that's it for this half of the lesson.